Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about function extensions or extension methods. This is a really interesting C# feature that allows you to extend classes without having to modify the code in that actual class. So usually if you have some kind of class, like for example over here I've got a myTransform, if you have it and you want to add some kind of function to it, usually you just modify the class and write the function inside of it. So for example, a public void move right, and then over here would take the position and increase to the right, something like this. Okay, so yep, that works. Here is the function. And up here, if we have something of type myTransform, if so, then we can go inside of this and we can indeed call the move right function. So yep, this works. This is perfectly valid code. We have modified the class to add our custom function and then we call the function. However, what happens if you can't modify it? Like for example, let's say I do want to implement this kind of move right function. However, instead of making it work with my custom myTransform type, instead of this, I want to work with the built-in Unity transform type. Now that type is sealed, I cannot modify it. So I can put transform for some kind of transform and we can try going to the definition. So here it is, except this class is compiled, meaning we do not have access to modify this. So the method of just writing the brand new function directly inside this class, this does not work because we cannot modify this class. So that's exactly where function extensions come in. Which again, remember how function and method are pretty much interchangeable names. So if you look in the C# docs, what we're talking about here is actually technically named extension methods. So extension methods or function extensions. This is basically how you can add extra functions to some kind of type without having to modify that actual type. We just need to follow a bunch of rules to make it work. The first thing we need is to be working on a static class. So let's make a static class. And then usually the naming rule is to name it something and then add extensions onto it. So in this case, we want to add some function extensions to the transform type. So let's call it transform extensions like this. That's the first rule. The second rule is the function needs to be defined as static and be public. So over here, a public static void, call it move right. And finally, the third rule for this one over here inside the parameters, the very first parameter, this one needs to have the this keyword. It needs to have that and then be the parameter of the type that you want to extend. So in this case, we want to extend the transform type. So let's put it transform like this. And if that works, so this is now a valid function extension. And now inside of here, we can do our regular code. So for example, we can do exactly what we're doing. So let's go inside this transform and modify the position and do a new vector 3 and just move it to the right. And if there it is, this is our function extension. And now up here, when we have access to a transform, like for example, the transform that this object is attached to, we can go through that one and we can call the function move right, and yep, it does work. And we can see over here IntelliSense is telling us, yep, this is an extension function. So we can call this, and yep, this works perfectly. So we've got no errors. Basically what is happening here is this keyword over here inside the function. This says that this first parameter is special. Basically it assigns what it was called on and uses that over here on the first parameter. So basically over here, this is doing the exact same thing as if we were to manually go inside the transform extensions, call the move right function and pass in this transform. So both of these are doing the exact same code. The only difference is this one is much easier to use. So yep, as you can see like this, we have added a brand new function onto this type, onto our transform, without having to modify the transform type itself. So we don't need any access to it. We just need to know the type and we can write an extension and then we can write some kind of code that works directly on that type. And of course, over here, after using this special parameter, so this parameter, this one has to be the first one, but afterwards you can add whatever you want. So let's say, for example, a float amount, and over here we modify this one by the amount. And then when calling it, we just pass in, for example, 3. And yep, this works. So we call the function extension, which is going to call this function. For the transform, it is going to use this one, and for the amount, it is going to use this one. And again, this works on any type. So over here, we are making a function extension that is extending the transform type. But for example, let's do another one. Again, we just need to make sure to mark it as static. And let's extend, say, the bool type. Let's make is true. This one returns a this, bool. And for example, just return if the boolean is true. So yep, again, all the rules are being followed. It's inside a static class. The function is static and has this keyword. So now up here, bool, and we can set it to something. And then bool.isTrue. And yep, this does work. So yep, we can add function extensions to some custom types. Or we can add to built-in types, can be a boolean, can be an int, can be literally anything. All of this works so we can easily extend any type with any functions we want. This works for extending classes, but also works for extending value types like we saw over here, the bool. So we can also extend structs, and this also works for extending interfaces. So if you want to add extra logic to a type, but either you cannot or don't want to modify the original type, that's where function extensions or extension methods come in. It's one of the best ways to make some helper utilities functions that you use a lot and make them super easy to use.